Nubaid Islam had the most beautiful vision of uniting Jews and Muslims through his world-famous kosher and halal smoothies. In his village in Pakistan, he borrowed a blender from his neighbor Mohammed Baghdadi and started to make the best and most beautiful mango and apple smoothies. The Jews and the Muslims in his village alike loved the smoothies, and they started to marry each other and get along because of how amazing the smoothie was. It cured the hunger problem in his village and started to make everybody much happier because of the nutrition in his smoothies. Nubaid had the vision of going to the United States with his smoothie idea, creating a little stand in Orange, Connecticut, and making his own smoothies for everybody to enjoy. However, both groups thought it was a little too expensive and wanted a better deal and a big discount on the smoothies. So when Nubaid opened up his stand in Orange, Connecticut, he had the goal of maximizing profit on those smoothies so both groups were happy and satisfied and could buy them without complaining. Therefore, he contacted a math teacher to help him with the calculus to try to maximize profit, get the most amount of smoothies, and still have great quality smoothies. At Islamo's Smoothie Shop, we specialize in making the best, most beautiful, and spectacular smoothies at an affordable price. For a 16-hour period, we want to maximize the amount of smoothies that we make and the amount of profit that we make. Each smoothie is $4 for the base price, but we do a 25-cent decrease in special sale for every 20 new customers that we get. The cost of making a smoothie is $2, and our X value is a 25-cent decrease from the base price. So the price of our smoothie goes from 4 minus 0.25x to 2 minus 0.25x. The number of smoothies sold, 100 plus 20x, will just represent that and it will stay the exact same. So for our formula to calculate profit, we do the number of them sold times our profit. And we are going to demonstrate how that works in our formula and by taking the critical number. So we use the exact same formula to calculate the max profit that we get. So that would be 2 minus 0.25x times 100 plus 20x. Once we FOIL that out, we get a formula of 200 plus 40x minus 25 minus 5x squared, which translates to 200 plus 15x minus 5x squared. So in order to find the max price, we have to do the critical number, which we have to do by finding the first derivative. The first derivative of this equation is 15 minus 10x. We get that through three things by separating the three terms. The first derivative of 200 is just 0. That applies to any single constant because there's no x value. The first derivative of 15x turns to just 15. The reason why is because our first derivative, by taking the power rule of n minus 1, the x just goes to 0 and there's no number to put in front of 15. Now for the 5x squared, that turns to just 10x. The reason why is because we put the exponent of 2 in the front, multiplying 5 by that, getting 10x. And then by doing n minus 1, x just turns into 1. So we get 15 minus 10x. In order to find the critical number, we have to equal that to 0. So that'd be 15 minus 10x equals 0. And by just distributing them to each side, we get 15 equals 10x, giving us a critical number of 1.5. That critical number means that to maximize our profit, we must do 1.5 25-cent decreases. So right here, we have to do a couple things. First of all, we're plugging x back into the original equation for both profit, both before and after expenses, as well as the number of smoothies sold, because we want to find a couple of values here. So by plugging in 1.5 for the profit equation, we get 4 minus 0.25 times 1.5. That translates to 3.625, round up, we do 3.63. That means each smoothie is going to be sold at $3.63. Now, given that each smoothie costs $2, we just subtract $2 from that and get $1.63 for our net profit after expenses are calculated. And for the amount of smoothies, we plug it into the formula where we do to find quantity. That formula is 100 plus 20x. So by doing 100 plus 20 times 1.5, we get 130 smoothies are sold to get the maximum profit. Now, in order to make sure that our critical number of 1.5 is correct, meaning that we have the max profit, we're going to do a first derivative test. So we're going to do two different intervals. One of 0 to 1.5, given that 0 is the minimum amount of price increases that you can do. 1.5 is your critical number. And the second interval of 1.5 to 16, meaning that 16 is the maximum amount of price increases until your number just goes to 0. So we're going to plug in two test values to see which interval is increasing, which is decreasing. So for the 0 to 1.5 interval, we plug in an x value of 1, and we get number 5, meaning that it's positive. So it's increasing on the interval of 0 to 1.5. Then the second interval, we plug in test value 2 to see if it's positive or negative. And we end up getting a negative 5, meaning that the interval is negative and is decreasing. We're plugging this into the first derivative equation, so there we get a positive negative number, and we see that 1.5 is the hill or the maximum value. So from there we know that 1.5 price decreases of 25 cents is the best amount to maximize profit. We sold 130 smoothies for $3.63 each. From there, we get a net revenue of $1.63, and we get a max profit of $211.90.